For lesson 4's homework, we're going to continue our work with our equations for our perpendicular bisectors. So if we look at this first one here, we want to determine and state the equation of the perpendicular bisector of the segment shown in the diagram below. So if you remember, there are 4 things to do, and the first one is to find our midpoint. So I'm going to find this first midpoint graphically. So I'm basically just going to count our slopes. So we are up 6 and over 12. So if we take half of both those numbers, we are up 3 and over 6. And that gets us to a midpoint of 0, 0. Okay. The next thing we're going to do is we want to find our slope. Well, we basically did that already. 6 over 12, which simplifies to 1/2. Then we need to find our perpendicular slope. So 1/2 turns to -2 over 1, or just -2. And then the last piece is to write our equation. Okay, and again, most of the time we do this in point slope. So y minus y1, so y minus 0 equals perpendicular slope as m, -2, parentheses x minus 0, if we use that midpoint. So just to clean that up a little bit, obviously you don't need the minus 0, you don't need the minus 0. So realistically what you get is you get y equals -2x as our equation, okay? If you had left it in its point slope form, that would have been fine. But I just chose to kind of clean it up a little bit. Number 2, Regents question. Segment CD is the perpendicular bisector of AB at E. Which pair of segments does not have to be congruent? And we kind of did this earlier in the year, but what I'm going to do is I'm going to draw my picture in a very specific way to kind of show you something here. So it's telling us that AB is what's being bisected, and it's being bisected at E. So I'm going to try to get E in the middle as best I can. And then when I draw that segment for CD, I'm going to draw it like this. Okay, and again, there are other ways to draw your picture, but I'm drawing it like this for a reason. Okay, so which set of segments do not have to be congruent? So if we look at AD to BD, now we did a lot of work with this with our compass earlier in the year, and it said that the end points of the bisected segment are always the same distance away from the bisector. So AD to BD does have to be the same, and the same for AC and BC. Now AE and BE, well obviously if that was a segment that was cut in half, those are going to have to be the same, and that leaves us with choice D. Remember, AB is the only thing that's being cut in half. CD is not being cut in half, it is doing the bisecting. So the distance from C to E does not have to be the same as the distance from D to E, which is why I made sure I drew my picture in this very extensive way, where it's very clear that the distances are not the same. So for A, B, and C, those have to be true, but for D, it might be true, but it does not necessarily have to be true. And number 3, I'm just going to cross out the page number here. Determine the equation of the perpendicular bisector of segment AB, given the endpoints of AB are A, -6, 1, and B, 2, 5. So let's plot them first. 1, 2, 3, 4, 5, 6. So -6, 1, there's A. B is 2, 5. So now, connect them with the segment. So if we're going to do it, we need to go through our same process. First piece is we're going to find our midpoint. All right, and I'm going to find this one algebraically, just because. So our x midpoint is the average of -6 plus 2. -6 plus 2 is -4. Half of that gives us -2. So then our y midpoint is half of 1 plus 5. 1 plus 5 is 6. Half of that is 3, giving us a midpoint of -2, comma 3. Nope, sorry, that's -1, comma 3. -2, comma 3. So there's our midpoint. Okay. The next thing we have to do is we have to find our slope. Same deal. I'm going to find this algebraically. y2 minus y1 over x2 minus x1. So that gives us 5 minus 1 over 2 minus negative 6. 5 minus 1 is 4. 2 minus negative 6 plus plus gives us 8, gives us a slope of 1/2. Third, need to make that slope perpendicular. So 1 over 2 gives us a perpendicular slope of negative 2. And then 4, for our equation, we are going to end with y minus 3 equals our perpendicular slope, negative 2, parentheses x plus 2, because it would have been minus negative 2, so minus negative gives us our plus. And there's the equation of our perpendicular bisector for that segment.